Hey guys, my name is Tensor. Welcome to another Go tutorial video. Today we're going to be talking about Docker and gRPC, and we're going to be building out a chat application. And the idea is that we're going to put the server of this chat application inside of a Docker container, and then we'll be able to connect to it from multiple different clients on the outside. Now, if you do not have Docker installed on your computer, you can go to their website, which is just docker.com, and you can go to Get Started, set up an account, and there are various different instructions to actually install the program. Alright, so now that we have Docker on our machine, let's get started writing our protobufs. So first, of course, we need to declare the syntax type that we're going to use inside of this file, and then we'll declare the package name. And because I've got this in a folder called proto, I'm just going to call it package proto. Now, because our application is a chat application, we want to set up a data structure that will represent the user or the client that's connecting to the server. So each user will have an ID, which will be a string, and a name, which will also be a string. Then, of course, the users need to have the ability to send messages. In our case, our messages will be associated with the user by the ID. So we'll put an ID into the message, content, and timestamp. All of these will be strings, of course. Now let's create a message called connect, and this will be the message that the server receives when the user actually connects to the server. So we pass in the user, and then we pass in a Boolean, which lets the server know whether or not the client is active. Now finally, we want to create an empty message, which I'm just going to call close, and I'll explain a little bit more about this when we actually get to the logic of sending and receiving messages. Let's now define our services. So I'm going to call this service broadcast, and the first RPC function that I want to define here is called create stream. And the idea is that we send in the connect message, and then this function will then return a stream of messages. So rather than just connecting and getting one message, we connect and then we get messages until there aren't any more messages. And so for this stream to actually work, we want to build another RPC, which will actually take the message and then return a close message. So you can sort of think of this like when we connect to the server, this function gets executed, and then we get a stream of messages, and then this function describes how we return those messages to the client. Now that we've finished building the protobuffer stub, I'm going to go ahead and get all of the include proto files and put them into the third-party folder like we did in the last tutorial to make things easier. And then I'll actually run the command to build the Go code. So we're just going to run proto c --protopath equals proto --protopath equals third party, and then --go out, plugins, gRPC, proto, and then the name of the file that we want to use to build our Go code. And this will, of course, give us a service.pb.go file inside of our proto file, and in here we'll have all of the structures and stuff that we're going to need to use to connect our server and our client to gRPC. Alright, so now that that's finished, let's go ahead and start building out our server. So I'm going to just put the server into the root directory of our project, which is just Docker example. And I'm doing this just for the sake of actually running Docker. Now with this server, we want to set up gRPC logger. And so we can create a variable here called gRPC log, and we'll connect it to glog logger version 2. And then we can create an init function which will execute when this application starts, and we'll just take this and we'll set it equal to glog new logger version 2, and we need to pass in the writers that we're going to use for info messages, for warning messages, and for error messages, which in this case will just be our OS standard out writer. So this will make it so that we actually see the various things that are happening inside of our gRPC server in our command line. Now let's go ahead and set up a structure which we'll call connection. This will have a stream inside of it, and our stream will point towards this little proto.broadcast create stream type, which is inside of our generated service.pb.go file. If we go to the definition of this type, you can see that it's just an interface. It has a little send function attached to it, and then it wraps around a type called the gRPC server stream. The whole idea behind this interface is essentially to allow us to expose behavior which will allow us to stream our messages between our server and our client. So we'll put that in the connection struct under the name of stream. Then we'll have an ID, which will be a string type. Then we'll have our active, which will be a boolean. And then finally we'll have an error, which will be of type channel error. And because we're going to be using Go routines, this error type needs to be a channel. Now that we have the connection structure defined, we can go ahead and define a server structure, and the server structure will implement our RPC, and it's essentially just a collection of connections. So it's just a slice of pointers to our various connections. Now, because our server is going to be the type that we're going to implement our gRPC on top of, we want to implement the two methods that we defined inside of our protobufs file. So first let's start with the createStream method. This will be a method on the server type. It'll take in the connection structure, which we're grabbing out of our proto file, and it will also take in a stream, which will again be that broadcast createStream server interface. Because we're going to be streaming the data to the client, we only need to return an error from this method instead of a tuple with the resulting type and an error. First, let's go ahead and create a connection for the client that is calling this function. So we'll say con equals connection. We need to fill out each of our fields here. So we'll take in the stream, which we're getting in from our parameter here. And then we'll have the ID, which we can get from our proto-connect structure. Then we'll set the active variable to true by default. And then finally for our error field, we'll make a new error channel. To close out this function, we can take the connection type that we just created and put it into our server's connection field by using the append function. And then we can return whatever error we're getting back from this channel by just saying arrow over con.error and then having the return statement before it. Now let's go ahead and implement the broadcast message method for our server type. This is more traditional in that it just takes in the gRPC context, and then it takes in our proto message type, and then as return it returns a tuple of a proto close type and an error. Now we're going to be using a lot of Go routines, so let's go ahead and create a wait group. The wait group is essentially just a counter that allows us to count the various Go routines that we have, and then what it does is it waits for the Go routines to finish and it decrements the counter accordingly. In this way we can block until our Go routines finish. Then along with our wait group we'll create a variable called done, which will be a channel of integer type, and we'll use this to know when all of our Go routines are actually finished. Now let's go ahead and loop through all of our connections inside of our server. So we'll say for connection in range of server connection, and then for each one we'll add one to our wait group because we're going to spawn a bunch of Go routines for each of our connections. These Go routines will execute an anonymous function that takes in the proto message type and a pointer to the connection itself, and the first line will defer the wait group is done, meaning when the Go routine is finished running, the wait group will be decremented. In this function, we're essentially going to be passing the messages back to the client. Now, if the connection is active, then we want to grab the connection and the stream attached to that connection, and then call the send method that's inside of the stream interface, which will send the message back to the client which is attached to this connection. After we've done that, we want to show that this has happened. So we'll use our gRPC logger and we'll issue an info message which says that we sent the message to our connection stream. If on the other hand we fail to send the message to the stream, then we want to make it so that the connection is no longer active, and we want to issue an error from our gRPC logger that says that we had an error from that stream and the error was this. So we can go ahead and pass in con.stream and then the error inside of this. And then finally, we want to pass the error that we got into our error channel on our connection. Outside of this for loop, we want to create yet another Go routine with another anonymous function inside of it. And this one is simply just a Go routine that runs and makes sure that the wait group will wait for all of the other Go routines to exit. And once it finishes waiting, we'll issue a close command to our done channel. And to make sure that we block the return of this statement until our wait group ends, we'll just make it so that the done channel needs to return an item before we can actually return from this function. And of course, the return will just be a proto close and then nil for the error. Now let's go down to our main function and set up everything. So first we need to create a connections variable, which will have the slice of pointer to connection type inside of it. Then we'll create a server type, which will be a reference to our server with the connections inside of it. Then we'll start up our gRPC server by calling gRPC new server, and then we'll get our listener and our error back from calling net.listen on TCP port 8080. And then of course we want to check to see if this error is nil or not. And if we get back an error, we'll just call log fatal f when we'll pass back that we had an error creating the server. If on the other hand we do not have an error, we can go ahead and set up our gRPC logger by calling back an info message which says that we started the server at port 8080, and then we'll go ahead and register our broadcast server on our gRPC server, and then we'll pass in the service, which will be the actual server type. And then of course we'll serve this on our listener, which is the port 8080 TCP connection. And that does it for the server component of our application. So now let's go ahead and create the client. And I'm going to create the client in a folder called client, and I'm just going to create a main.go file here. Again, this file will be package main, and we'll have our main function inside of it so that we can execute it independently of our server. We'll start by creating a global variable for our proto broadcast client, and then we'll set up a wait group, and we'll initialize that wait group using an init function. Then after we've done all of this, we want to create a function called connect, which will take in a proto user and return an error. First we'll start by declaring a error type, which we'll call stream error, and then we'll call client.createStream, which is our RPC function. This takes in the context, which we'll call context background, and it also takes in a connection structure type. The connection structure type, of course, needs a user, so we'll pass in the user, which is coming through this parameter, and then we'll pass in the active field, which will be true when we actually connect to the server. If we get an error back, then we'll pass back that we had a failure with our connection, so we'll just say connection failed. We want to spawn a bunch of Go routines. So we'll use our wait group and we'll increment it by 1, and then we'll create an anonymous function which takes in a proto broadcast create stream client interface type. This is the stream that we got back from calling create stream. And if we actually go to the type, you can see here that it again is an interface that wraps around this gRPC create stream type. And that create stream type essentially allows us to define the behavior that we're going to need to implement the streaming part of our client. Now again, we want to defer wait.done so that we can know when the Go routine ends so that we can then decrement our wait group. And then we'll create a for loop which will go on infinitely. Inside of this for loop, we'll call to our broadcast create stream client, and we'll call the receiveV function. What we're essentially saying here is wait for us to receive a message from the server, and then we can go ahead with our logic. Now if we receive an error from calling string receiveV, meaning we don't get a message back from the server, then we want to go ahead and create an error in our stream error type, and we'll just say that there was an error reading the message, and then of course we'll put the error in here, and then we'll break out of the for loop afterwards. Otherwise, we'll go ahead and actually print the message that we received back from the server so that we can actually see it inside of our terminal. So we can just use fmt printf, and we'll pass in the message ID. This is the user's ID that sent the message, and then the message content. So the actual message that's being sent as a string. Then finally, at the end of our connection function, we'll return our stream error. Now down in our main function, we want to go ahead and set up a timestamp. So we'll just say time.now to get the current time. And then we'll also set up a integer channel called doneAgain. We want to allow the user who's executing the client to enter their own username. So we'll say name equals flag.string. And the flag that we'll pass to the client will be an N, a capital N. And if they do not pass in a flag, then the name will just be a non by default. And then of course we have the little helper string which just says the name of the user. After we get the name, we can go ahead and generate an ID for the user. And we'll do this by using the timestamp that we got, and we'll concatenate it with the name of the user. Then we'll convert it into bytes, and then we'll use a SHA-256 hashing function on it to create a hash. So each of the users will have their own ID, which will just be a hash. And actually, before we make our ID, we need to call flag parse so that we actually have a value inside of our name variable before we go and create the actual hash. Now let's go and set up the logic for our gRPC client. So we want to connect to localhost 8080, which is where our Docker container will be serving our server at. And of course, we're not using HTTPS, so we'll say gRPC with insecure. Then we'll deal with whatever error we get back, and we'll just say couldn't connect to the service and then pass back the error. And after that, we can then create our new broadcast client on the connection, and then we can create our user structure by passing in the ID, and we'll call hex encode to string on the ID, and then we'll also pass in the name. Let's now take our user and pass it through the connect function that we defined above, and then we'll increment our wait group because we're going to create another go routine. This go routine will just take an anonymous function that takes no parameters and returns nothing. And on the first line, we want to call defer wait done so that we know when it finishes. Then we can go ahead and create a new scanner so that we can actually scan the input from the user. And for this, we'll use standard input. So the user will input through the command line, and then it will create the message using that input. And we can create a for loop which loops until there's no more input from the user. And for each of the loops, we'll create a new message where we pass in the user ID, the content, which will come from the scanner, and we'll just grab it by calling scanner.text, and then the timestamp, which will be the current time in string format. Then we can go ahead and call client broadcast message, pass in our context background, and then the message that we just created. And if we get an error back, we'll print out that there was an error sending the message, and then of course show the error. And of course, if we have an error, then we want to break out of the for loop. Then at the end of our main function, we want to create yet another go routine. And this of course is like before, where we're just waiting for our wait group to actually decrement all the way down. And then when it does, we can call close on the done channel. And then we basically just wait until the done channel sends back something. So our client will not end until done sends back some data. Now if we want to, we can check to see if our application runs before we put the server into Docker. And we can do this simply by running the server and the client. So I have two command lines open. I'm going to run the server here. And when I do, it gives us back that it's serving the server on port 8080. And then if I go into my other command line and run the client, it will actually show us nothing until we type something in. So I can just type in hey and then hit enter, and it will then send back my ID for this client and of course the message that I just sent. And if we go back to the server, you can see here it says sending message to, and then we actually get a hexadecimal representation of the stream for the client that it's actually sending the message to. We now know that our application works properly. Now let's go ahead and set up Docker for this application so that we can put our server inside of a container. The idea is that we put the server into a container. This allows us to then build out the application and then run it in a self-contained and a very small environment. In this case, it'll be a Linux container, which will just have the Golang compiler inside of it and the tools we need to actually build the application and then run it. So first we want to define the type of container that we want to use, and I'm going to use this very small container called Golang Alpine, which is just a small Linux container with the Golang tools inside of it. So we use this from keyword, and then we're going to just say that this will be our build environment. Next, we want to define an environment variable. Because we're using the Go mod system, we need to make sure to turn on that module system. So we'll just say environment variable go111 module equals on, and then this will set up that environment variable for this container. Now, because the container is pretty small, we're going to need to get a few tools so that we can actually build our application. So we can go ahead and run a package manager inside of the container called APK. So first we want to update the sources for APK. So we'll run APK update, and then we'll run APK add, and we'll add bash, which is of course the bash shell. Then we'll get CA certificates. This is for SSL, and we'll probably not use it, but it's usually a good thing to have it. Then we'll get git, which is the git command line tool. Then we'll get GCC and G++. GCC is just a normal C compiler, and then G++ is a C++ compiler. And then we'll get libcdev, which is a bunch of developer include libraries for C and C++. Now we want to go ahead and actually set up the directory structure for this container. So we'll make a folder in the root directory called docker_example, and then we'll make another folder called proto inside of the docker example folder. We can then go ahead and say that our work directory is the docker example folder, and then we can go and copy the service pb.go file from our proto folder over to the docker example proto folder in the container, and we can also copy our main.go file right here into the docker example folder in our container. We also want to copy over the go.mod and the go.sum files. These give us the dependencies for our Go project. And of course, we are just going to put them into our docker example file. We can just use a dot in this case, because it'll just put it into the work directory, which we're already inside of. Then we go ahead and get our dependencies by calling run go mod download. Then we go ahead and build the actual server by running go build, and we want the output to be a file called docker_example, and we'll do it again with which will just be inside of our docker example folder. And then finally, we want to specify the command that we want to execute when we run the Docker container. So we'll just execute our server by calling $docker_example. And this is of course why we wanted to install bash into our container as well. Now I can go out into our command line and I can run docker build, and I'm going to tag this container with the name docker_example. And I wanted to build with the files in the directory that we're currently in, so I'll use a period. And of course, when we execute this, you can see it goes through all of these steps. So it gets the Golang Alpine build, then it sets the environment variable, and then it sets up all of the directories, and it goes and it downloads the dependencies and all that stuff. Now once it's finished building, we can go ahead and run it, but we want to run it with a few special flags. So we'll say docker run -it-p to set up the port binding, and we want to bind port 8080 inside of the container with 8080 on our local machine so that our client can access it. And then of course we want to run the container called docker example, which we just tagged. And as you can see, we get back our info message like we did when we just ran this application natively. but the main difference is that now it's inside of our Docker container. And now with our server container running, I can go ahead and run 2 clients in 2 separate command lines. So we'll go ahead and run the clients and we'll specify some names. So I'll give the top client a name of tensor and the bottom client a name of foo. And now we can start to send in our messages. So I've sent in hi there from the tensor client. And you can see here on our server, we have multiple messages sent to the 2 clients, and it appears on the second client here. And then I can respond with this client. I can just say hello, and you can see that again it goes through the server and then it sends to both of the clients. Anyway guys, I hope you enjoyed this surface level tutorial on Docker and gRPC. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you disliked this video, then by all means downvote it as much as you like. Have a good night.